Hello everybody, welcome to MATLAB Unit 3. In this video, we're going to start with a little bit of review of some stuff that we've seen earlier in this MATLAB course, but then we're going to see an example of some behavior that's very strange, and we're going to talk about why this behavior happens, and we're going to talk about some solutions to it, and how we're going to kind of deal with this moving forward. So let's start with some review. Let's say I want to create the vector that goes 2 squared, 2 cubed, 2 to the 4th. How could I do that? Well, I could say 2. Let's raise it to the vector 2, 3, 4. And if I just press enter, this is going to give an error. What is it? I need to use the dot caret because I'm doing element-wise exponentiation. So I'm going to do 2 dot caret. And now what this says is take 2, raise it to the power of 2, then to the power of 3, then to the power of 4. So we can see here we get 4, 8, 16. That's looking good. We've also seen some built-in constants. So already a number of times in this class we've seen pi, and I can see here's a rounded version of it, so 3.1416. If I wanted more decimal places, I could say format long. Oops, let me do it like this, format long, and then let's type pi. And we can see here, I get many more decimal places. I'm gonna put it back to format short though. We also have the constant e. If I just type e into MATLAB, MATLAB doesn't know what that is. So the way we get e is we type exp and then parentheses and 1. So the way you want to read this is e to the power of 1. If I were to replace this 1 with a 2, it would be e squared. If it was a 3, it would be e cubed, and so on. So we can also make the same type of vector. So here we raised 2 to a bunch of powers. I could also define a vector v, let's say, where I take pi, and let's make the vector that goes pi, and then it goes pi squared, pi cubed, all the way up to pi to the 8, let's say. Oops, and I really should have ended this with a semicolon. I'm not too interested in the output. So there's pi to the 1 through 8. Now I'm going to do the same thing with a vector w, except now instead of going pi, pi squared, pi cubed, it's going to go pi to the negative 1, pi to the negative 2, all the way up to pi to the negative 8. So how do we do that? We can say start at negative 1, go down by negative 1, go to negative 8. And again, I'm going to use a semicolon to suppress the output. And okay, so now we have two vectors, pi, pi squared, pi cubed, up to pi to the 8. And then we also have pi to the negative 1, pi to the negative 2, down to pi to the negative 8. So imagine now that I multiply the elements of these vectors component-wise. So I multiply the first elements together, the second elements together. What do we expect the output to be? Well, I'm taking pi times pi to the negative 1, that should be 1. Then I'm taking pi squared times pi to the negative 2, that should be 1. So every element should be equal to 1 when I do the product. So I can do v times w. And again, if I just type it like this, there's going to be an error. I need the dot to let MATLAB know I want to do element-wise multiplication. So I'm going to suppress the output. And let's also give this vector the name u. So what's going to happen if I do something like u double equals 1? So before we do that, let's do a quick reminder. So what this does is it checks every element of u and it says, is it equal to 1? Now what we expect is yes, everything should be equal to 1, right? Because we're taking pi to some power n and multiplying it by pi to the negative n, so that should just give us 1. And remember, so the length of u is 8 because there's 8 elements, and its size is a 1 by 8. So when I do u double equals 1, I expect a 1 by 8 row vector that has a 1 everywhere where u is equal to 1 and a 0 everywhere where it isn't equal to 1. Oops, and let's see what's going wrong. I'm saying u double equals 1. Invalid expression. Something strange is happening. Let's see. There it goes. I think there was probably something going on with, oh yeah, see here, I had the 1, 8 in my command window by accident. That's fine. I really just wanted to do u double equals 1. So don't worry about this part. I think it was just an error with me mispressing some keys. But okay, let's focus on u equal to 1. So notice, okay, it's 1, it's 1, it's 1. Something strange here, 0, right? And also 0 here. So we're saying pi to the 4 times pi to the negative 4 is not equal to 1. And pi to the 8 times pi to the negative 8 is also not equal to 1. So that's very strange, right? Because if I do something like pi cubed times pi to the negative 3, and I say, is this equal to 1? MATLAB says, yes, that's equal to 1. But if I do something like pi to the 4 times pi to the negative 4, is that equal to 1? MATLAB says no. So what's going on here? And the takeaway, so what I want to emphasize is the fact that it's pi to the 4 and pi to the 8, that's not important for us. We don't need to worry about why is it for these two cases. What is important and what's the takeaway of this video is that MATLAB has a certain amount of numerical precision that it can work with. So computers are finite. They can only store finitely many bits. We can only have so much accuracy of a number. So what that means, especially for when we're working with irrational numbers, so pi is transcendental. We could also have this issue with root 2, which is irrational. Basically, some rounding is going to occur. So anytime we ask, oh, is this equal to 1? There's a high chance that even if mathematically we know it's 1, because of rounding, it's not going to return true. So kind of again, the takeaway is when we're working with real numbers in MATLAB and also coding in general, we should never expect something to be exactly equal to something else. And the way we get around this is we come up with a tolerance. So we say, okay, maybe it's not exactly equal to 1 in MATLAB, but maybe the difference between them is very close to 0. So I could say, okay, well, is the difference between pi to the 4 times pi to the negative 4 minus 1, is that smaller than 10 to the negative 8, let's say. So for instance, I can say, okay, pi to the 4 times pi to the negative 4. And let's say I subtract off 1 and I want to ask, is this less than 10 to the negative 8? So I'm saying, is this distance small? Now, what's one thing I've done here that's off is when we're computing distances, I should have it in absolute value. And this is just because I'm interested in how far away from 0 am I. I'm not worried about the sign attached to it. So I can say here, okay, is the distance between this product and 1, is that less than 10 to the negative 8? And MATLAB says true. So what's the takeaway is that, okay, well, maybe it's not exactly equal to 1 in MATLAB, but it's close enough to 1 that it doesn't really matter. So it's going to return true. And I hear now that the lawn mowing has started in my neighborhood, so this is a good place to end the video. Thank you so much for watching, and I will see you in the next one.